So here we're looking at different expressions in index form and we're trying to simplify them into just one expression which is in index form. So in 2a we've got h to the power of 4 times h to the power of 7 times h, and we need to remember that the h has an invisible power of 1 that we don't normally put. And when we're multiplying we add the powers, so we are doing 4 plus 7 plus 1, and altogether that equals 12, and therefore my answer is h to the power of 12. Now in 2b we have a fraction, and the easiest way to consider it is just by splitting that fraction in half to match up our coefficients, 20 and 8, and also to match up our indices over here. Now 20 over 5, as it always has been, is 4. Okay, 20 divided by 5 gives us 4. And then on the right hand side we're going to consider the powers. So we have the same base a, so we're going to do 8, and because it's divided that means we subtract the other power. So 8 subtract 4, which is 4, so our final answer is 4a to the power of 4. Now in 2c it's a division question, and so again that means we're going to subtract the powers. So this time our powers are 3 subtract the negative 4, and then we notice that as we have two negatives next to each other, that's the same as a plus. And so 3 plus 4 gives us 7, therefore our final answer is b to the power of 7. Our final question is a multiplication, and of course with multiplication we know that we can change the order around. So essentially we have 3 times d, because we know in algebra invisible time signs exist between things where we've got them written side by side. So we have 3 times d times 2 times d to the power of 7. And once again, the single d has an invisible power of 1. And with multiplying, we just said we can change the order. So we can write this as 3 times 2 times d to the power of 1 times d to the power of 7. And then we work it out in stages. So 3 times 2 is 6, and d to the power of 1 times d to the power of 7. Adding the powers gives us d to the power of 8.